Hello. open. So that's what we're testing for. And then we say if that's the case, then we set status inner text equal to closed. Otherwise, or else, status inner text equals open. All right, save that. Back in the browser, click on the button, and watch up here on lid status. Click the button, it changes. Click the button, it changes again. All right, so now our event listener works, and you can see an event listener appended to a button can influence anything else in the DOM. That's kind of the whole point. We now have complete control over everything that happens in the DOM through an event that we are tracking ourselves. There are so many different DOM events to listen to, and there is literally no limit other than your imagination to what you can do with an event listener when an event is triggered. In this practice example, I want you to just dive headfirst into event listeners and events to explore what events exist and what you can do with them. In the practice files, I've set up a grid for you to play around with. You can listen for events on the grid as a whole, to individual cells in the grid, or just do something entirely different. It is entirely up to you. Nevertheless, here are some suggestions on what you can try out if you want to. Use an event listener to add CSS either inline or through an added class to draw a highlight around the entire grid when you hover over it, and then take the highlight away when you move your mouse out. Add an event listener to each grid cell to highlight that cell when you hover your mouse over it, or add an event listener to each grid cell to change its background color when you click on it. You can add an event listener to a specific key on the keyboard and change the background color of a whole page from dark to light and back again, or do something else. To get started and to get some ideas, I recommend visiting the MDN event reference page and looking for some specific events you want to test out. As an example, the key down and key up events allow you to detect what key is pressed and when that key is released on a keyboard. Now that our event listener is working, we need to expand its functionality a bit. For one thing, the button text needs to be updated to reflect what the button actually does. Right now it says open lid when the lid is closed, and when I click on it, it also says open lid when the lid is open. So it should really say closed lid when the lid is open and vice versa. Secondly, we need to update the property for lid status in the object itself. So if that object was living in a database and we wanted to pass that object back into the database to change the status, we could do that. This serves as a good example to highlight an important issue when choosing whether to use an arrow function or a function declaration as the event listener callback. Let me show you what I mean. In our event listener here, we are targeting the button element and then adding an event listener to it. So if I want to change the text inside the button element, I can do so by simply calling the button element inside the event listener, saying inner text, and set it equal to something else, like changed. And save that. Go back in the browser and click the button once, and now it says changed. All right. So it works. That means we can copy this ternary operator below here and just apply it. So then we say button instead, copy that 3 times. So we're targeting the button, and then we'll say, and then instead of just saying open, we say open lid and close lid and open lid. And the funny part is it doesn't actually matter what order you do this in inside the ternary operator. You could say close lid, open lid, close lid, and it would work the same way, because all we're doing is looking at the existing string and then swapping it for something else and effectively just toggling it back and forth. So if we go here and look at this now, if I click open lid when it's closed, it'll now say close lid when it's open and vice versa. Okay, so the logic here works. Now I mentioned this whole arrow function versus function declaration. Right now we're using an arrow function. You see it right here. And you'll remember when we talked about arrow functions previously, I said arrow functions don't have their own this. That comes into play here because ideally we should be able to say, instead of button, just say this. So this inner text, meaning this object that we are currently interacting with. And just do that across here, this inner text, and this inner text. And that should work in theory, right? We're inside an object. But if you look closely, you'll see when I do this, we get this grayed out text behind it because the browser is saying, probably not actually working, but we can try it. So let's open the console and click the button. And when I do so, it says, cannot read property inner text of undefined. What's happening here is this arrow function doesn't have its own this, so it doesn't know what object we're pointing at when we're using this. So if we want to use this inside an event listener, we need to change it to a function declaration. So we say function, and then take away the arrow, save, and now everything works again, because now we are working inside a proper object that has this, so we are able to point at this. So why am I showing you this? Well, once we get more advanced, we need to have the ability to control whether we want to use this or not. So if you scroll up to the top of this file, I've also added a new function up here called lid toggle. And that's because when we start working with a lot of different things that are happening, it doesn't make any sense to have the entire function sitting inside the article generator. We want to separate the function out. So here you can see we have a function declaration called lid toggle. Inside, we first set up a new let called backpack object. Then we grab the backpack object array. That's the array that has all the backpack information. And we use the find method to find a specific element. Here we want to find the ID inside all of those elements. And we want to see if that ID matches the ID of the parent element of the button we clicked. So the article down here will have the ID for the current element, and then we're using that ID here. So we say the button, the parent element of the button, which is the article, find the ID of that article, then put that in as the ID and use that idea to see if you can find an element in the array that matches. That will give us the object in question. Then we can say backpack object, that's the array object we just found, then set lid open to true, and then we're using a ternary operator. Then we do the same thing down here. Here's the this inner text that applies to the button itself. And then finally, here we have this parent element query selector and then the backpack lid span. So that is the text inside the backpack lid status. And this also is just the ternary operator we've been working with before. So we can use this function instead as a callback function. To do that, we'll go down to our event listener and just wipe out all the content inside. And in place of the anonymous function, I'll just put in the name of the function we want to call, which is lid toggle. Now, like I said in the previous movie, this is a callback function, so we're not putting the parentheses at the end here. We are calling the function back into the event listener and then running it in the event listener. And that's why this statement up here still works, because this function is now effectively part of the event listener down here, thanks to the callback. Save this, run it in the browser, click a button, everything is working properly. So now we've effectively created an advanced event listener, separated the callback function out into a separate function, and we are using a function declaration to be able to access the this keyword and point at the button element. Working with event listeners, you'll often want to either access the event object inside the callback function or pass some argument through to the callback function. It's not immediately obvious how to do either when we are working with callback functions, so let's take a closer look. In the earliest example of an event listener, you may remember I called in the event object as a parameter in the arrow function, and this is the answer to the first part of the question. You see, whenever you set up a new event listener and you have a callback function, the event object is automatically passed to the callback function as an argument, and we can choose to capture that object and use it in the callback function by setting up a parameter name for it. So in this case, I've set up the name event, and then we use it down here. The passing of the event object happens automatically. And this is actually the answer to how to do it externally as well, because this entire thing here is just an anonymous callback function. What we have here instead is we're calling in the callback function, but what we're really doing is saying take the entire lid toggle function and just put it where the lid toggle keyword is. So if we want to gain access to the event object, we just need to call it event and then console log event. Save that, go check in the browser, and everything is working as it did before. And that's really all there is to it. If you just want to get a hold of the event object, simply name it as a parameter and use it, and you have it available to you. But what if we want to pass a proper argument into the callback function? Let's say I set up a new argument here and set it equal to some text. Looking at the code we have, you can clearly see I can't add parentheses here and then pass the argument directly, because then I break the code. So I have to do something else. And what I'll do is quite literally cheat. So right now we're using lid toggle as the callback function. I will change that. So instead we set up an anonymous function as the callback function, and that anonymous function will wrap around lid toggle. Now we can call lid toggle as a proper function and pass whatever we want to lid toggle. So now I can pass new arg directly to lid toggle. And then up here in the function, I need to change this to new arg and console log out new arg. Did I spell that correctly? Yes, yes, yes. Okay, save that. Go back in the browser and click the button, and we get the argument, but we also get an error. Cannot read property parent element of undefined. So what is happening here? Well, first off, we were able to pass the argument through to the callback function, no problem, but we also broke our callback function in the process. Why? Well, it's because in the callback function, you'll remember we are using the this keyword, but this now refers to the internals of our arrow function. So that's not going to work. That means we need to pass the button element on as an additional argument and then use that instead. So we have the button element here. We can pass it on. So now we have button and new arg as arguments. That means we need to have two parameters up here, button and new arg. Then I'll just change all of these references to this to button instead. Save that, back in the browser, test it, and now you can see everything is working again. Cool, so now thanks to the cheat, we're able to pass any arguments we want into the callback function. But what about our event object? Well, the answer is straightforward. We capture the event object here, just like we did before. This just makes it available to us, and then we pass the event object as well. So event, comma, button, comma, new arg. Scroll back up to the function, say event, comma, button, comma, new arg. Then we can console log out the event. Click the button, and now we have both the event and the arguments passed through. This here is a very common pattern for using event listeners. We are working around the problem of not being able to pass arguments into a callback function by using the callback function as a function wrapper to call other functions. That way we have full control, we can do whatever we normally would do in a function call, and we still have access to the event, and we're still using the event listener as intended. All right, one final challenge. Here, you'll be adding event listeners to our existing project. In this challenge, you'll create an event listener to allow the user to update the strap length for each of the backpacks independently, and each backpack has 2 straps. The end result is what you'll see here in my browser. For each of the backpacks, we now have 2 input fields, one for left and one for right, and if I add a new value here, and click update, you'll see just this left strap length updates and then just the right strap length updates. And we can do that independently for each of the bags. This entire functionality is powered by 2 forms. So there's a form for each of these items. Inside the form is an input field and a button. And there's an event listener listening to the submit event on the form. Then when the submit event is triggered, the script grabs the value from the input and then passes the value up into the HTML here so you can see the output. Now, while this is a form and we haven't worked with forms before, everything that is done here has been covered in the course already. A form is just like any other element, and you can grab properties out of that element and use it in different ways. For this challenge, I've created two different paths for you to choose from. You can choose the intermediate path or the advanced path. In the exercise files, these two are captured in two separate files. We have script intermediate.js and script advanced.js. And to start the exercise, you pick one of these two files and then just change its file name to script.js, and that becomes your main file that you work with. The difference between the two is, in script intermediate, you are focusing solely on the event listener and nothing else. It's described at the top here. Create an event listener by adding an event listener to each of the strap length forms and then updating strap length value to the value submitted in the form. In script advanced, there's a lot more going on. Here you have to set up the entire functionality. So you have to first find the two elements with the backpack strap class, then create a function to output the strap length form, iterate through each of the items, then capture the value of the data side attribute to indicate the strap side, either left or right, create a form element, populate the form element with an input and a submit button, and finally add an event listener and output the content. This mention here, data side attribute, if you scroll down into the content, you'll see that each of these two items here with the class backpack strap has a data side attribute, left or right, and you can use these to indicate which one of the sides you are on right now with classes and such. If you choose script intermediate, I encourage you to finish the challenge, then watch my solution where I explain how script advanced works, and then go back and redo the challenge using script advanced to immediately solidify your learning. After all, the purpose of these challenges is not for me to test your knowledge, but for you to challenge yourself. And what better way to do that than to first do a simple challenge and then expand and do an advanced version of the same challenge. Like I said, everything that's in this challenge has already been covered in this course. There's nothing new introduced except that we're using a form, and forms work exactly like any other element in HTML. This challenge is the last one in the course, and I made it quite challenging. So set aside a good 20 minutes before you jump to the next movie to see how I solved it. All right, let's look at how I solve the create an event listener challenge. When I take on a tricky challenge like this, the very first thing I think about is what I want the HTML to look like in the end. So first, I went into the browser and messed around to build out the form that I want to inject. So here you can see that form. I placed it inside the list item with the class backpack strap. Then I set up a form that has a class that indicates what side we're on, so left length, and then the other class would be right length. Then I create an input inside. It's an input with a type number, so it only receives numbers and nothing else. I give it a name, left length, so that I can point at it if I need to. And I set up a placeholder for this input so that it says new left length and new right length when nothing else is input. It's a placeholder, so if I start typing, you can see the value goes away, and if I take the value away, then the placeholder comes back. Then there's a button, and it's just a button. It does nothing. It has no name or anything. It just says update because I can target the button easily using standard JavaScript. All right, so this is what I need to build. A form for each of these items, and there's 2 items in each backpack. In the exercise files for this movie, I've extensively commented everything that's going on to make it easier for you to see how all of this works. So if we go from the top and scroll all the way down past the huge template literal we've been working with before, you'll find here on line 116, I've set up a new item that says let strap lengths, backpack article, query selector all, backpack strap. So this will create a node list for me inside strap lengths that has the 2 items. So both of these list items that have the backpack strap lengths. Right now, they're just outputting strap length and nothing else. So what I want to do is grab the objects so that I can inject more content into each of those objects and return them back. Then I've created a new function called new strap lengths, and I pass this strap length node list to that function. So that way, I now have the 2 objects in question, the 2 list items, and I can work on them independently. This function, new strap length, sits up here on line 46, and it captures the strap array. So the node list is effectively an array. It works the same way. Inside the constant, I've created an arrow function, and in the arrow function, I start off by saying strap array for each list element. So I'm immediately going into each of the items in the strap array. So now, from here on forward, I'm working on list element, which is the element for each of the list items. Then for each of the list items, I first use this list element get attribute to get the data side attribute. You'll remember, data side is populated with either left or right, telling me which side I'm on right now, and I'll use that later on. So that's captured in the let called side. Then we create a new constant called length form. This is the constant that will create the form, and I use document create element to create the form element. Then I immediately give length form a class, and here I use side and the string length to create either left length or right length as a class. That will make it easier for me later to target just that element if I need to. So it's always a good idea to just append classes whenever you can. And you can see here I'm using a template literal to mix the side value with some text. So now we have the form element. Then we need to put something inside the form element. And here I'm just using inner HTML as we've done before with the template literal. In the template literal, I set up an input with the type name. Then I set the name to, again, side. That's the value from up here. Length. And the placeholder is new. And then I use side again, length. And that's what you see in the browser here. You see it says new left length and new right length. So left and right here are this side let that sits up here. So now the form element has an input and a button. Then I can append an event listener to each of these forms. So now I can grab length form and add an event listener. And what I'm listening for is the submit event on the form itself. So when you click a button inside a form, it always submits that form. Now the tricky part is a form, when you submit it, will try to reload the page. So the first thing I do is capture the event. Then inside my arrow function, I say event.prevent default. All this does is prevent the browser from reloading the page immediately, so we're preventing the default behavior of the form. As a result, the form does nothing, so now we need to make the form do something. What I'll do is get the value from the form input, so we set up a new let with the name new value, then we grab length form, use the query selector to find the input, that's the input up here, and then we grab the value of the input, so that will be whatever is inside that form element, whatever's inside this form element here. Now we have the value set as new value. Then we use list element. That's the current list item we're looking at. We use query selector span to find the span. You'll remember span is what contains 53 inches in this case. Then we set span's inner HTML equal to the new value. So that is the new value we got out of the form and inches. Then finally, because we now no longer need the form input itself, I grab length form, query selector input again, so that's the form input, and then I set its value to nothing. That means when I type in a value here, 82 or 84, click update, you'll see it clears out, and then the value sits up here. Now that we've used the form, we've reset the value, we exit our event listener, and the final thing we need to do is just append this new length form, so the entire form, to the list element. Now remember, the list element is the list item, and by appending the form, we are adding it to the end of the item after all the other children, and that's why in the HTML here, you see we have the list item, then we have the text, we have the span, and then the form at the end. As I said in the setup to this challenge, there's nothing new here. And as you can see now, there really is nothing new. We're using the same methods as before and the same methodology as before. It's just that we're working with a form, which looks a little bit different than other things, but works exactly the same way because, as you now know, everything in JavaScript is an object. The document is a giant object. All the elements inside the documents are objects. And we can treat objects the same way no matter where we are and what we're doing. Writing JavaScript is one thing. Getting it to work properly is quite another. As you start writing your own JavaScript, you'll often run into issues you need to troubleshoot. You've already seen the most heavily used troubleshooting tool in action throughout the course. It's the browser console. Here you can log anything from your code into the console to see what's going on. And you typically do this if you're capturing values and then want to see what the values are before you start working with them. So here in this code example, I'm grabbing this variable called strap array, and I just want the console log it out to see what it is. I'm also console logging out an element down here. And when I jump over to the console, you can see the output. We have a node list with some items in it, and I can burrow into them, and I'm also getting the output I want. So this console log is used all the time to send values to the console so you can see as you're iterating through your code what is happening and whether you're getting the values you're looking for. The console log is also a live coding environment, so you can write whatever code you want here, and it's effectively like writing JavaScript in a file, except you're doing it live in the browser. So you can run code in the browser and test it right away directly from the console. If there are errors in your code, let me see, I'll introduce one here and save it. The console will also try to tell you what's wrong. Typically, it'll tell you some sort of error message like uncaught syntax error, and then say missing parentheses after argument list, and it'll give you the file the error occurs in this case script.js, and the file line. So here we are on line 50. In most cases, this error message will be fairly accurate and will tell you what's wrong. So in this case, it'll tell me there's a missing end parentheses. And when I look here on line 50, there's a missing end parentheses. And combined with the tools in the code editor, you should be able to figure out what's wrong. However, in some cases, due to how JavaScript works, you may have an error inside a function, for example, but the error gets kicked where the function is called. So it's not always immediately obvious where the error is sitting and what that error is. And these console log error messages are not always the most helpful. For this, we have more advanced troubleshooting tools in the browser. Now, I could create an entire course just focusing on these tools. So for now, let me just give you a quick preview. If you open the exercise files for this movie in the browser, then I'll open the developer tools and go to sources. Here you'll see all the files that are currently being used in the browser. So if you're ever wondering, I wonder if there's an image file or something else that's available, you can actually get a full breakdown of everything that's being run in the browser right here. What we're looking for is the script.js file. And when you click on this, you can see the entire script.js file here. So this is the same file that we created in the exercise files, and it's now being previewed in the browser. From inside this tool, I can now start troubleshooting by doing things like adding a breakpoint so that I can step through the code and see exactly what's happening. What I want to do here is grab this new strap length function. I want to see what is happening as this function is executed. So I'll take my mouse and click on line 43 here. This adds a breakpoint. Now I need to reload the browser with this window open. Now, at the very top of the page, it says paused in debugger. So this is the debugger, and I've currently paused the code here on line 43. Now, what you're noticing is inside the debugger, I now get the value of strap array displayed here next to it. So I can scroll through and look at everything that's being sent here. And as I step through this, and I can do that using this button over here or hitting F9 on my keyboard, I literally step through the code line by line. And the browser will stop at each line and tell me what is going on. So here I can watch this list element be broken into a for each loop so that we now have a single list element. And if I step to the next one, it says this let side now has the value left, and it comes from the list element. And I keep stepping down. Now we have this const length form, and here's the value of length form. And we can keep stepping down through this code and see exactly what's going on. Now, this is really useful if your code isn't doing what you intended to do and you wonder, what on earth is going on here? Are the wrong values being passed? Where is it crashing? Where is the values breaking? Because you can see live in the browser what values are being passed down, when functions are kicking in, and what they're doing. And you can add as many of these breakpoints as you want by just clicking these lines here. And these breakpoints will be triggered every time you reload the browser as long as you are inside the debugger. Like I said, these tools are well outside the scope of this course, but now that you know they're there, I urge you to inspect your own code here and make yourself familiar with how they work. It is quite literally what I showed you. Just open up the code file, click on a line, and then step through the code to see what's happening. At the very beginning of the course, I said, for a lot of people today, their first interaction with JavaScript is through a JavaScript framework like React or Vue. And I said, if you understand the fundamentals of JavaScript itself, you'll be able to understand what is going on inside a JavaScript framework like React, even if you don't know the framework or the framework-specific language. We started out by looking at this React component, and now that we're at the end of the course, we can revisit the same component to see what is going on so that you can see how all the things you've learned apply to React as well. Off the top, the component imports two items, React from React and prop types from prop types. You now know what this means. It means somewhere else in the project sits something called React and something called prop types, and we're just importing it into this component so that we can use it in that component. Then there's a constant called image with click that sets up an object that has a single property, cursor and pointer. In React, developers prefer to use objects for pretty much everything. So you'll see a lot of the time when you want to save any kind of data, you save it in an object because objects are very easy to work with. And as you've seen through this entire course, objects are the core piece of JavaScript. So placing data in objects just makes sense. Scrolling one more line down, we get the main exported component from this file. Now remember how we set up a class earlier and I put the class in a separate file and then exported the class out? React components work exactly the same way. So you can think of a React component as a React version of a JavaScript class. Here, the developer has defined a const called photo, capitalized. And if we scroll all the way to the bottom, you'll see photo is exported down here. So if we call this file, you get the photo component, or the photo class, and then you can make an instance of it. What happens inside the photo component? Well, first it sets up a series of parameters, just like we did with the class. So here inside the parentheses, we have a list of all the parameters or properties that are going to be used inside the photo component. Then there's an arrow function that captures all of these properties and uses them to do different things. Inside the arrow function, we can do a myriad of different things. In this case, a new constant is set up that has another object. This one is called image style and has an object that sets some properties for CSS, so margin and display. And then below, there's a conditional statement that tests to see is the current layout a column or not. And if so, it sets some other properties, position, left and top. Then there's a click handler. This is an arrow function that effectively does the same thing as an event listener. So it listens for an on-click event on the current object, and then it does something, and then the component returns content. So here we have what's known as JSX. JSX is an extension to the JavaScript coding language that allows you to output content in an even simpler way than when we use the template literal. So you can see it looks very similar to a template literal, except you don't have the backticks and you don't need to put the dollar symbol in front of these curly brackets to make it work. But looking at this, you can see that the formatting is exactly the same, and you recognize that these pieces behave the same way as everything else we've been working with so far, just a tiny bit different because it's in React. Scrolling even further down, we have an export of a constant called photo prop type. This one uses the prop types that was imported at the very top and sets up a shape for the objects. What's happening here is the developer has set up a set of rules for what the different properties in this component must look like. So it says the key property must be a string. The source property must be a string, and it also is required for the component to output content and so on. Then scrolling down, we have photo prop types, and this is a standard object. So here we have a set of properties, and then we have a set of methods, and these methods uses arrow functions to pass values. Now you'll notice the methods are using arrow functions. In JavaScript, you can't do that because then everything breaks, but because this is inside React, you can actually use arrow functions inside your methods. That's just an idiosyncrasy of React. And then finally, like I said, we export out the photo component or the photo class to make it work. Now here's the thing. You don't need to understand what's going on in this particular React component. I mean, I pulled this out of a larger React project, and it's a standalone piece of code that does nothing. If you run it, it will do nothing. It doesn't work in the current context I'm presenting it. My point with all this is, now that we've gone through all these different things in the course, you can recognize all the pieces of this component, even though you've never touched React before, even though you don't know JSX, and even though you may have never had experience working with JavaScript at all. Understanding the fundamentals of JavaScript gives you the tools and language you need to be able to understand what is going on in JavaScript frameworks, because JavaScript frameworks are built on top of vanilla JavaScript. Now you have the tools and you are ready to get started on your learning journey to extend your knowledge into JavaScript frameworks as well. Oh, right, you're still here. As we wrap up, I wanted to tell you a short story about my learning journey with JavaScript for some inspiration as you embark on your own learning journey. All the way back when I started working on the web, JavaScript was something we really didn't use all that much, partially because it wasn't all that useful, and partially because it was very tricky to use. When years later I did start adding JavaScript to my sites, it was usually through jQuery or some other helper library, and it was still limited to minor interactions and features. To be honest, I was actively resisting JavaScript for a very long time because it seemed way too abstracted from what I thought of as the real work of the web, writing proper semantic HTML and CSS. That all changed when I realized I could use JavaScript to do things that were very hard or even impossible to do using HTML and server-side frameworks like PHP. That big epiphany for me came when I realized JavaScript allowed me to pull content from any data source as an object and then do whatever I wanted with that object. And suddenly, the way I thought about JavaScript was turned on its head. No longer a tool to add minor interactivity, JavaScript became my primary tool for consuming and parsing data, managing HTML and CSS, and building websites and applications. The key to all of that was realizing in JavaScript, everything is an object. Those objects have properties, and those objects have methods that act on those properties. And that's the lesson I've tried to share with you in this course. Now that you're at the end of this course, you have a solid foundation from which to start your own learning journey in the wild and wonderful world of JavaScript. We have a long list of more advanced courses on vanilla JavaScript, on JavaScript frameworks like React and Vue, on REST APIs and GraphQL, and all the other things JavaScript brings to the table. And they are all ready and waiting for you to take the next steps. I want to leave you with two insights. JavaScript is always evolving, and it's worth the effort to stay on top of the latest and greatest the language has to offer. If you're new to JavaScript right now, invest your time in learning about modern features. The stuff we used to do in the past is in the past. The future is where it's at. Number two, your success in learning and working with JavaScript hinges on how you approach it. If you think of JavaScript as a cryptic coding language, it will remain a cryptic coding language to you. If, on the other hand, you think of it as a way of talking to a computer about objects and methods, that's how you'll understand it. Everyone can learn to master JavaScript. It's all about attitude. And just between you and me, the key is to have a healthy disrespect for the sanctity of code. Do what you want. Break the code. Poke around and mess with it until it makes sense to you. You're working in the browser. It's a safe environment. You can do whatever you want. And remember, the MDN web docs have a ton of documentation and examples on hand, and the web community is full of people like me you can reach out to if you have questions. So do not hesitate to ask when something is confusing or doesn't make sense. Now all that's left for me to say is lykke til, go build some amazing things with JavaScript, and I'll see you in the next course. Oh, right, you're still here. As we wrap up, I wanted to tell you a short story about my learning journey with JavaScript for some inspiration as you embark on your own learning journey. All the way back when I started working on the web, JavaScript was something we really didn't use all that much, partially because it wasn't all that useful, and partially because it was very tricky to use. When years later I did start adding JavaScript to my sites, it was usually through jQuery or some other helper library, and it was still limited to minor interactions and features. To be honest, I was actively resisting
large number of programming scenarios. Hi, I'm Joe Marini, and I've been building software professionally for some of the biggest and best-known companies in Silicon Valley for more than 30 years. In this course, you will get a hands-on introduction to the Python programming language. We'll start off by learning how to determine if Python is installed on your system and how to install it if it isn't already there. Next, we'll see how to build our first Python program in just a few lines of code. Then we'll examine the basics of the language: data types, variables, loops, functions, classes, and more. We'll move on to working with some of Python's built-in high-level data types, such as dates, times, and files and directories. And finally, we'll wrap up by taking advantage of Python's extensive library of pre-built modules to build advanced features like retrieving data from the internet and processing information such as HTML, XML, and JSON. If you're ready to start building the next generation of cross-platform applications that run on the client as well as the cloud, then let's get started learning Python. Before we get started, there are some concepts that you should already be familiar with in order to get the most value out of this course. This course is designed to quickly get you up and running with the Python programming language. It is not intended to be a general introduction to the fundamentals of programming itself. You should already be familiar with the basic principles of programming, such as variables, functions, statements, and so on. If you're not familiar with these concepts, I suggest you watch Foundations of Programming Fundamentals before taking this course. It does a great job of introducing the fundamentals of programming. If you have prior experience with other programming languages like JavaScript, that will also be very helpful. And it's okay if you don't, you will still be able to benefit from the course. But JavaScript has some language features that are kind of similar to the things we'll run into in Python, so having some knowledge of JavaScript will help, but again, not required. You should also know how to use some common programming tools, like your operating system's terminal program, and a text editor or an integrated development environment. If you need to brush up on using an IDE or text editor, consider watching Learning Visual Studio Code, which is the editor I'll be using in this course. Once you feel comfortable with these concepts, you can go ahead and get started. I've provided a set of exercise files to accompany this course, which you can download from the associated GitHub repository. You can see here that I've placed them on my desktop so that they're easy to access, but you can place them wherever is most convenient for you. So let's open the folder and take a look at how they're arranged. You can see that the exercise files are arranged according to the chapter that they correspond to in the course. So let's open up one of the chapters. Each exercise file has a name and ends with either _start or _finished. The _start version of the file is the starting point of that particular exercise that I will use to build towards the finished working version. The finished version right here is the corresponding code in its finished state. Now, how you use these exercise files is entirely up to you. If you want to use the start version and then follow along with me as I build toward the finished version, well, that's great. If you want to jump ahead and just look at the finished version to see how everything works, well, that's great too. It's entirely up to you. So once you have the exercise files folder downloaded and you've got it where you want it on your system, then you're ready to go. Let's begin by making sure that Python is properly installed and configured on your computer. So here on my machine, I'm going to open a terminal window, and then in the terminal window, I'm going to type py. I can also just type the word Python by itself, but I'm going to type py-version and hit the enter key. And you can see that I'm using Python 3.9 on my computer. Now, if you're on Windows and you didn't get a result that looks like this, the word Python followed by a version number, then you probably got some kind of error message or the version number you have is less than 3.9. So in either case, that means you need to install the latest version of Python on your machine. So let's go over to the Python website. This is the Python website located at python.org. And I'm going to go ahead and click on the downloads area right here. And you can see that there's a link to download the latest version, which is the 3.x series. And for this course, you should use at least 3.9. And you can also see that the downloads page defaults to the version for my operating system, which in this case is Windows. And there are download links provided for a variety of other OSs. Now, I've already done this for my machine, so if you need to, go ahead and download and then run the installer by clicking on this button right here. It's a very simple process and should take only a few minutes to complete. And then go back and try that terminal test again that we did earlier to make sure that everything worked. That's pretty much all you need to do. So once you've got Python installed, you are ready to continue. Installing Python on the Mac is pretty much the same as installing it on Windows. Now, the good news is if you're watching this on a Mac or Linux machine, chances are you've already got Python installed on your system, but it might not be the most recent version. The Mac ships with Python, as does many versions of Linux, so you might already be good to go, but you can make sure you have the right version by following along with me. So here on my machine, I've opened a terminal window, and if you're on a Mac or Linux computer, then just use the terminal program that came with your system. So I'm going to type Python 3, and this is important. If you're on a Mac or Linux, you'll probably need to type Python 3 instead of just Python by itself or Py, because Py only works on Windows. So type Python 3. And the reason is because some systems come with both the older Python 2 as well as the newer Python 3 installed. So I'm going to type Python 3 -- version. Right, and you can see that I'm using Python 3.9 on my computer. Now, if you didn't get a result that looks like this, the word Python followed by a version number, you probably got some kind of error message, or maybe you got a version number that's older than this. And that means that Python is not on your computer, or you need to go get the latest version. So let's go do that on the Python website. So this is the Python website, located at python.org, and I'm going to go ahead and click on the Downloads button. And you can see here that there's a link to download the latest version right here. Now this page might look a little bit different when you get here, but it'll look pretty similar, and how to download this will be pretty obvious. So you can see that there's a link to download the latest version, and there's also links that download to other versions for operating systems. So if you need to, go ahead and download the Python installer that's appropriate for your computer, in this case the Mac, and then install it, run the installer, and then try the terminal test again that we just did. So once you've got Python installed, you're ready to continue. There are a lot of great tools out there for working with the Python programming language, and in this course, you can use any code editor that you want. I'm going to be using Visual Studio Code from Microsoft. It has great support for Python editing, and it's free, and it runs on Mac, Windows, and Linux. It also has a wide variety of plugins available, which will help when working with Python. So if you want to use VS Code along with me in this course, then download it from code.visualstudio.com. You just come to the site right here, click on this little download button, and it'll download the proper version for your operating system, and then go ahead and install it. Now again, just want to remind you that VS Code is not a requirement. You can use any editor that you want. In a separate video, we'll see how to run the example files directly from the terminal. So you can go that route if you want to, or if you're using a different editor. It will still be very easy to follow along with the rest of the course. So once you have Visual Studio Code installed, launch it, and then once it's launched, click on the extensions icon, which is this one right here, these little square boxes. Once you've clicked on the square boxes, up here in this little search box, we're going to type the word Python, because we're going to install the Python extension. And usually it's the first result. It's this one right here. You can see it's from Microsoft. It has a ton of downloads. There are other options for working with Python, but this is the one that you should be using. So go ahead and install that one. And if I go back to my list of installed extensions, you can see that I've already got Python installed, and it should automatically install this Pylance language server for you. So just install the Python extension and you should be ready to go. So this extension adds support for debugging and running Python apps right from within Visual Studio Code. And when you install it, if VS Code asks you to restart, then go ahead and do that. All right, so once we've done that, we're going to take a few moments and we're going to set up some of the preferences and settings that are going to make VS Code easier to use. So first, make sure that VS Code is using the version of Python that you installed. Now, usually this is set up for you, but let's make certain. So we're going to open the exercise files folder as a VS Code project. And you can either click on the open folder button here, or you can drag and drop the folder onto the application window. I'm going to go ahead and click on open folder, and then my exercise files are on my desktop, so I'll select that folder. All right, so I've got my Python project now open, and we'll give VS Code a moment to go ahead and activate its extensions. All right, and then in chapter 2, go ahead and open up the hello world _start file, and you can see down here VS Code says it's activating its extensions. All right, and then you should see over here in the status bar the version of Python that the IDE is using. So if you click on this little text, you'll see this pop-up appear, and this gives you the opportunity to choose the interpreter that you want to use. And you can see I only have the one version of Python installed. So just go ahead and select that version number and you should be fine. Now, if you don't see this little text label down here in the corner, that's not common, but it might happen. What you can do is use a different way to select the right Python engine. So in the View menu, you can choose either the Command Palette option right here, or you can just type Control-Shift-P on the Windows machine. It's Command-Shift-P on the Mac, and that will open up this little pop-up. Then type Python Select, and you can see that there's an option for Python Select Interpreter. So go ahead and select that one, and you'll see the same pop-up appear. And then just choose the Python interpreter that your machine has installed. And after you do that, you should be all set. So now let's open up the settings for VS Code. And on Windows, you can type Control, or Command, on the Mac, or you can find it in the menu bar. So let's go ahead and type Control, and here in the search box, I'm going to search for a preference named Execute in File dir, right? And that's this preference right here. Make sure that it's checked and then save the preferences. So this preference tells VS Code to look in the same directory as the program's source file when it needs to work with other files, which we will see later in the course. All right, that's pretty much it. So once you've got VS Code installed and set up along with the preference changes, then you are ready to proceed. During this course, we're going to be building and running some example programs. And as I demonstrated earlier, I'll be using Visual Studio Code during this course, and we've seen how to get that set up in a previous video. But using VS Code isn't required. You can use any editor you want, and it's important to know how to run Python programs outside of the development environment that you're using. So here's what we're going to do. First, open the terminal program for your computer. On the Mac and Linux, this is usually called terminal. On Windows, this is either PowerShell or the regular command prompt. Now, it's beyond the scope of this course to explain how the terminal works, so if you're not familiar with it, you'll need to read up on it on your own. From here, let's go into the exercise files directory, which is wherever you put it. So here on my system, it's on the desktop. So I'm going to go into the desktop, and I'm going to go into the exercise files folder, and let's list that. All right, so I've got my chapters. So let's go into chapter 2. All right, and inside chapter 2, we have a program called Hello World _finished, right? So to execute a Python program, we use the Python command like this. I can either type py on Windows. Now this doesn't work on the Mac, but on Windows you can type py, or you can type Python by itself, and that's the name of the Python program. And remember, on the Mac or on Linux, it'll be Python 3. And that's because Macs and Linux machines usually have an older version of Python, the 2.7 series, and usually Python is mapped to the older series. So you'll type Python 3 on the Mac or Linux. So here on Windows, I'll type Python, and then the name of the Python program file we want to run. So I'm going to type hello world, and I want to run the finished version. And when I hit the Enter key, you can see that the program runs and prints hello world and asks me for my name. So I'm going to type Joe, and it says, nice to meet you, Joe. And we'll see how to build that program later. But all of the examples in this course can be run this way. So if you choose to use a different development environment than Visual Studio Code, or even if you are using VS Code and just prefer running the examples this way, then you have this option. Now that we have Python installed and our tools set up, it's time to start writing some actual Python code. But before we fire up our text editor and just start diving in, we're first going to use Python's interpreted mode in the command line interface to see how easy it is to write and run Python. So here I've started up my terminal program, and you can do the same on your computer. It doesn't matter if it's Windows or Mac. And I'm going to type Python by itself and hit return. And remember, on the Mac, you're going to have to do Python 3. So I'm going to type Python, and when I do this, you can see that this places me into Python's interpreted mode. Right, so right here is the version number for Python, and then there's some help text, all right? And then there's this little 3-angle bracket prompt right here. Now, in this mode, I can just simply type some Python code, and it will run immediately. So I'm going to go ahead and type 2 plus 2, and you can see that the answer comes back as 4. Now, Python is an interpreted language like some other common ones in use today, for example, like JavaScript in the browser. In other words, it's not like Java or C or C++. The application does not need to be compiled and then built into an executable before you can run it. The Python interpreter simply takes each line of code as it comes across it and then interprets and executes the code. And in this case, it's simply taking the numerical expression 2 plus 2, evaluating it, and it gets 4 back. All right, let's try a different line of code. I'm going to write print, and then a parentheses and a quotes, and type in hello world, and then quotes, and then a close parenthesis. All right, I'll hit enter. And now you can see that I've executed the simple Python statement print, which is a built-in Python function, and we'll learn more about functions, along with the string of characters hello world. Don't worry about understanding all of this right now. It will become clearer as we go through the course. All right, let's try one more thing. I'm going to write name equals input, and I'm going to type what is your name, question mark, and then close quote and parentheses. And when I hit enter, you can see that now Python is running the input function, which gives me a chance to enter a value. So I'll type Joe and hit enter. So now I've created a variable, and that variable is called name, which contains the value that this input function asked for. So if I just type name by itself, you can see the value that the name variable contains, which is Joe. Now, all of this is not how you would normally write and run your real Python programs. I mean, obviously, real programs are going to be a lot more complex than this. But you can use the Python interpreter in command line mode to try out some simple things. Okay, now let's type the word exit, and with an open and close parentheses, so we're actually calling the exit function, and that will exit us out of the Python interpreter and then back into the terminal command line. Okay, so now we've seen how to write and execute some basic Python statements. Let's start up our code editor and write our first Python program. And I'm using Visual Studio Code, but again, you can use whatever editor you like. So here we are in VS Code, and I'm going to open up chapter 2. And here in chapter 2, I'm going to open up the file named hello world start.py. So let's start off by printing out a hello world message, right? So I'm going to type print, and you can see that as I'm writing my code, right, visuals here in VS Code, I'm getting statement completion right as I'm typing, and that's because of the Python extension that we installed earlier. So I'm going to write print, and then I'm going to write hello world, and that's pretty much it for that line. And then let's also have the user enter their name. So I'm going to write name equals input, and I'll write what is your name, and then I'll print nice to meet you, and then outside the closing quotes I'm going to put a comma and then name. Alright, so let's go ahead and save this, right? And we can start up a terminal window and go into the directory for the example file and run it like we did before. Or if you're using VS Code and you've got the Python extension installed, you can also click this little icon up here, which it says, you can see when I hover it, it says run Python file in terminal. Or I can right click in the source code and choose run Python file in terminal. So I'm going to go ahead and do that. And you can see that when I do that, the program is running in VS Code's built-in terminal here, right? And you can see that hello world is being printed. And here's the input for what is your name. So I'll type in Joe. And it says, nice to meet you, Joe. And then the program exits. So far, so good. Let's change a couple of things. So I'm going to click on this little trash can and get rid of this interpreter right here. And what I'm going to do is define a function. We'll learn more about functions later in the chapter, so just bear with me for the moment. I'm going to write def, which defines a function, and I'm going to call the function main. And then I give it an open and close parentheses, and then a colon, all right? Now, when I do that, you can see that this little red squiggle appears here. That means I'm getting an error. You can see it says expected indented block. So what I'm going to do is indent each of these lines under the function main. So I'm going to hit the tab each time, okay? And it's important that all of these lines be indented using the same number of spaces. And you can see that I've got 4 spaces of indenting. Doesn't matter if it's 2 or 3 or 4, it doesn't matter. They all have to be the same. Now, again, I don't expect you to understand all of this right away. We're going to be going into this more deeply as the course goes on. But what I'm doing here is defining a function. And that function contains our print and input statements. So I'm grouping all of these statements into one function that I can call elsewhere in my program. The Python syntax is a little bit different than other languages you might be used to. So Python actually uses the indentation level of the lines of code to indicate where that code belongs. So because under the definition for the main function, I've got each of these lines indented by 4 spaces, that indicates to the Python interpreter that these lines of code belong to the function main. All right, so now I need to add some code to actually execute the main function. So what I'm going to do is I'm going to write if _, name, and then _ again, is equal to, and then inside quotes, _ main, and then _, and then a colon. And then once again, I have to indent. I'm going to call main. So why do we need to do this, and what does it do? So unlike in C# or Java or other programming languages, Python does not automatically look for a specific function when the program starts. So what's happening here is this line of code right here, line 11, is checking to see that this module, this file of Python code is loaded, and the interpreter has assigned the _ name variable the value of main. That means that this Python program was executed as a main program. It was started from the command line or invoked from the Python executable somehow, and therefore this function right here, the main function, should be called. Now the reason I need to do this is because Python code can be used multiple ways. My code in this file can be run as its own program, but I can also build a reusable module that can be included inside of other Python programs. So if I were using this code in another program, I wouldn't want all this code to just start running when it was imported into the other program, because that would cause problems. So lines 11 and 12 help distinguish between when a Python file is being included in another program or when that Python code is being executed as its own program. So in this case, the file is being executed as a program, and this if condition right here will evaluate to true, and then the main function will be called. All right, so once again, let's save, and I'm going to go ahead and right-click and choose Run Python File in the terminal, and you can see that we are getting the output just as we would expect. All right, now let's take a look at how the Python language works with variables and data types. So in my editor, I'm going to open up the variables _ start file. And there are 5 major data types in Python. There are numbers, such as integers and floating point values, strings, which are a collection of characters, Boolean values, which can be either true or false, sequence types, such as lists and a data type called tuples, which are immutable, meaning they can't be changed, and dictionaries, which map unique keys to specific values. And so you can see here, I've defined a set of variables that represent each of these data types, and I have a set of print statements that print each of these values. So before we do anything else, let's just go ahead and run what we already have. So I'll right-click and choose Run Python File in Terminal. And remember, if you're not using VS Code, you can just run this in your terminal program like we saw earlier in the course. And you can see that the output contains the values of each of the variables that we've defined so far. All right, so far so good. Let's go back to the code. All right, let's try adding a couple of lines. I'm going to write my int equals ABC. Okay, and then I'll print my int. So now I've got my int equals ABC. So basically, I'm redeclaring the variable that was declared up here previously as a number. So now I'm declaring it as a string. So let's go ahead and run this. And you can see that it works. It started out as an integer, but now it's a string. So even if a variable has already been declared, you can redeclare it with a different type, and that works just fine in Python. All right, let's keep on going. Okay, let's take a moment to look at sequence types. So for sequence types like lists and tuples, we can access individual values using a square bracket notation with the index of the item that we want starting from 0. So to take an example, if I wanted to access the third item of my list, I would write something like this. I'd write print my list, and then remember it's a 0-based index, so I would use index 2. And the second item of my tuple, for example, would be index 1. And you can also use what's called the slice notation to access a subset of a sequence. So for example, if I wanted to get the first index here all the way to the end of my list, I would write something like this. So I'll print my list. And then I'm going to write 1 and then colon and then the number 5. So basically the two indexes that I want to get a subset from. And slices also take a third optional parameter, which is what's called the step value. In other words, it's how many items to skip over. So for example, to get the second through the fifth items in my list while skipping every second one, I could write something like this. Let me just copy this and paste it. So basically, this is the start index, the end index, and the step value. Okay? So let's go ahead and save. And let's go ahead and comment out the previous prints to avoid muddying the output. Alright, and we've already seen this one too, so we can comment that out as well. Alright, so let's go ahead and save, and let's run. And now you can see that we're getting... Let's go ahead and scroll that up. Alright, so we have the third item in my list, the second item, which is index 1 of my tuple. Here we have items 1 through the end, right? So this is the second, third, fourth, and fifth item in my list. And this is the second and fourth item because we're skipping every second one in my list using the step value. All right, let's keep on going. So what's interesting is you can use the slice notation to actually reverse a sequence. So there's a neat little trick you can do. I'm going to print my list. And then inside the square brackets, I'm just going to put 2 colons and then a -1. So I'm not specifying a start value. I'm not specifying an end value. So it's going to be the default start and the default end, which is the entire sequence. And then the step value is going to be -1. So this is actually going to reverse the sequence. So if we save and we run, you can see that now here's the original sequence. And here it is in reverse order just by using the trick right here to do the minus step. Okay, so far so good. Let's go back to the code. Let me comment out the previous calls here. All right. Dictionaries are a little bit different. Dictionaries don't work with indexes. What happens is you give them the key of the item that you want, and they return the value associated with that key. So if we scroll back up and we look at the dictionary here, we can see that the string 1 maps to the value 1 here, and the string 2 maps to the value 2. Now in dictionaries, the keys have to be unique values, but the values don't have to be unique. So if I wanted to retrieve the value associated with this key of 1 right here, what I would do is write something like this. I'm going to print out my dict, and it's going to be inside quotes the key of 1. All right, so let's go ahead and run that. And you can see that the key of 1 maps to the number 1. Okay. All right, let's go back to the code. So let's make another change. And let me go ahead and comment that line out. All right. Let's see what happens when I try to combine two different data types. I'm going to print a string type. All right, so this is a string. And then I'm going to use the plus operator with the number 1, 2, 3. All right, so I'm going to save that. And I'll try to run it. And you can see that I'm getting an error. And right here, you can see specifically I'm getting a type error. And this is happening because Python is what's called a strongly typed language, even though you don't have to declare the type of a variable before you use it. So what happens is when Python goes to execute this code, right here, it infers a specific type for a value or a variable. So you can't go back and change the type or combine it with other types. So I've got a string and I've got a number, which are two different types. I'm trying to combine them. And in Python, this doesn't work. You have to have all of the arguments be the same type when concatenating a string like this. So let's make an adjustment. I'm going to use the stir function to convert the number into a string. So what I'm doing here is using this built-in function in Python called stir. And that's going to convert this integer into a string. So that way I'll have a string plus another string, and that works just fine. So let's go ahead and save. I'm going to close that terminal and run this again. And now you can see that that works just fine. It's printing out string type 1, 2, 3, just as we would expect. All right, a couple more things to look at. Let's take a look at global versus local variables. I'm going to go ahead and comment that out. So I'm going to define a function and add some code to it. Now, I don't expect you to understand this right away. We'll get into functions later in the course, but for now, just bear with me. So I'll declare a function called sumFunction. And I'll have a variable called myStir, and I'll assign it the value of def, and then I'll print myStir. All right. So inside the function, you can see that I've got these two lines indented by some spaces, indicating that they belong to this function here. So in Python, indentation and white space matters. So I've got myStir equals def, and then I'm printing myStir. Now remember, if we scroll back up, I've already declared myStir up here. And so I've got a myStir variable here that's global, which is set to this is a string. And then I've got my local variable here, which is set to def. So let's add two more lines. I'm going to call the function, and then I'm going to print myStir. So let's go ahead and run and watch what happens. So you can see that when I run this, the value gets printed def, which is inside the function. But even though I've reassigned the value of myStir to def, once we get outside the function, it's back to being this is a string again. Now, that's because when you're inside a function definition, the function gets its own local copy of whatever variables you declare inside the function. So this variable, myStir, right here, is different than the global one that's defined up at the top. Now, if I actually want to affect the value of the global variable, I have to tell the function that there is a global variable named myStir, and that's the value it should make changes to. So what I'm going to do is I'm going to write the word global, and then I'm going to use the variable name of myStir. So the global statement with the name of the variable indicates to Python that this variable exists in the global namespace and is declared somewhere else. So now if I save this, And let's close that terminal and run it again. See, now you can see that DEF is being printed twice. And the reason is because now I'm affecting the global value outside the function, because I've told Python, hey, that's a global variable. When I change the value, it's going to affect the variable globally. So let's make one more change. Below this code, I'm going to write del myStir, and then I'll try to print it again. The del statement deletes the definition of a variable that was previously declared. So when I get to this line here, print myStir, there should be a problem. It should give me an error because that variable is gone now. So just for clarity's sake, let's make sure that all the other functions are commented out, and yes, they are. All right, so I'll save, and I'll run. And you can see, sure enough, here's the previous code. We're printing out the DEF twice, and then you can see name error, name myStir is not defined, and that's because right here on line 54, I've deleted the variable, which essentially means you can undefine variables in real time by using the del statement. All right, so that's a quick look at using variables and data types in Python, and we're going to take what we've learned in this video and we'll use it throughout the rest of the course. Most applications, regardless of the programming language that they are written in, are broken up into smaller blocks known as functions, and Python's no different. Functions give us a way of organizing our programs so that they are more understandable and modular. In this example, we're going to take a look at how functions work in Python. So in my editor, I'm going to open up the functions_start file, and we're going to start off by defining a function. So functions are defined with the def keyword along with a name. So I'll name my function func1, and then I'll use open and close parentheses. Now, this function doesn't take any arguments, but we'll get to that in a little bit. And next comes a colon character. The colon indicates that you're starting the scope or body of a function. And other languages like Java and C, for example, use curly braces for this, but Python uses the colon and then white space indentation. So I'm going to add a print statement here. This is print I am a function. So you can see that the print statement is indented by 4 spaces. And it's up to you how many spaces you want to indent your code. It can be 4 or 3 or 2 or 8. It doesn't really matter. The important point is that it has to be indented to indicate that the statements belong to the function. All right, so down here at the bottom, let's add a few more lines of code. So we'll call the function by using its name and some parentheses. And then we'll print func1. Again, using the parentheses, and then we'll print func1 just by itself with no parents. All right, so now let's go ahead and save and run, and let's watch what happens. Okay, so in the result, you can see that I am a function got printed, followed by the same strings as I am a function again, followed by the value of none. So what's happening is this. In the first case, the function is being called directly, which executes the contents of the function, causing the print statement to print the string, right? After all, that's what the function does. So that's simple enough. In the second case, the function is also being called inside the print statement, right? So the output is the same as the first case, okay? But then the outer print statement executes. And since our function doesn't return a result, Python evaluates the return value to be the constant of none and prints that. So these 2 lines right here are both the result of this statement right here. So when func1 gets called, it prints out this string, but then the print function prints out the return value of the function. And since there is no return value, the value is none. All right. In the last case, the function itself is not actually being executed since we're not including the parentheses. We're just printing the value of the function definition itself, which evaluates to this string right here. That represents the function object that we've defined. So this demonstrates that functions themselves are objects that can be passed around to other pieces of Python code. Now, we're not going to do that right now, but it's interesting to know that functions, just like any other object in Python, are values. You can just pass these around. Okay, so let's go ahead and try a couple of different examples. So let's define a function that takes some arguments. So once again, I'll use the def keyword. I'll call this one func2. And inside the parentheses, I'll have arg1 and arg2. Once again, I'll have my colon. And inside the function, I'll simply print arg1, separated by a space, and then arg2. Right? And then I'm going to define a function that actually returns a value. So I'll define a function named cube, and that takes one argument named x. And I'm going to use the return keyword to return a value. And I'm going to return x times x times x. Okay, so now let's go back down to our code down here, and let's add a few more lines to evaluate these new functions. So I'll call func2 with the values of 10 and 20. And then I'll print func2. And once again, I'll call it with 10 and 20. And then, oh, one more parentheses there. There we go. And then I'll call print cube of 3. So first, I'm defining function 2. It takes 2 arguments. And all it's going to do is print out the 2 arguments with a space between them. And then I have my function called cube, which takes a number and then returns that number multiplied by itself 3 times. So basically it calculates the cube value of the number and returns it. All right, so let's go ahead and comment out these previous statements. And let's save and let's run this. All right, and you can see that on the first line we've got 10 separated by space and then 20. And then on the second line, similar to the first example, we've got 10, a space, and then 20. But again, there's no return value, so it simply returns the value of none. And then for the cube function, we print the cube of 3 and get the value 27, because 3 times 3 is 9, 9 times 3 is 27. So in this case, the function does return a value, and that's what gets printed. All right, so far so good. Let's go ahead and add another example. I'm going to define a function that takes arguments and supplies a default value for one of the arguments. So I'll define a function called power, and that's going to take an argument called num, and another argument called x, and I'm going to write x equals 1. I'm supplying a default value in case it gets called without an argument for x. So inside, I'll have a local variable named result, and set that to 1. And then I'm going to have a for loop. Now, again, we haven't covered loops yet, so just kind of bear with me for a second here. I'm going to have a loop that goes from I to the range specified by x. And I'm going to have result equals result times the number. And then once that loop is over, we'll return the result. So, in a nutshell, I've defined a function called power. It takes 2 arguments. One of them is called num, one's called x. It takes a number and raises it to the given power. Now, you notice here that I've got x equals 1 in the function definition. This assigns a default value for that argument. Now, again, don't worry about loops too much, but the idea here is that we're going to loop over the number of times that this value is passed to us and multiply the number by itself that many times, right? So now let's add a couple of lines to execute this and try it out. So I'm going to print power of 2 just by itself, and then I'll print power of 2, and I'll pass in the value of 3 for the second argument, right? So in the first example, I'm calling the function power, but not giving it a value for x. So x is going to default to 1. And then the next call calls the function with num equals 2 and x equals to 3. So that's going to return 2 to the power of 3. Let's go ahead and comment out these previous ones. All right, and let's run again. All right, and you can see that 2 raised to the first power is 2. And then 2 raised to the third power is 8. Okay, so let's add one more test. What I'm going to do now is write print power And in this case, I'm going to reverse the arguments. I'm going to say x equals 3, and then num equals 2. Right? So in this case, I'm reversing the order in which the arguments are called. So Python lets you call functions with their parameters being named along with the value. So when you do this, the Python interpreter figures out which arguments to supply the values to. So you don't have to call the function with the arguments in a particular order as long as you supply the names along with the values. So let's try this again. So you can see that in this example, we get 2 raised to the third power in both cases, so the answer is 8 in both cases. So we've got one more example to look at. I'm going to define a function that takes a variable number of arguments. So I'm going to define a function, and it's going to be called multi-add. And the arguments are going to start with a star, and then I'm going to call the arguments args. I'll have my colon, and I'll have a local variable named result. I'll initialize that to 0. Once again, I'll have a loop. So for x in the args, I'm going to write result equals result plus x. And then I'll return the result. So what I've done here is I've defined a function called multi-add, and the star character means I can pass in a variable number of arguments. So the function is going to loop over each one of the arguments and add them all to a running total, and then that's going to be returned as the result. So let's scroll down. Let's go ahead and comment these previous ones out, and then I'll print multi-add, and I'll pass in some numbers. Let's see, 4, 5, 10, how about 4 again? All right, so let's go ahead and save, and let's run this. And you can see that the result is 23. So I'll change the function call to include another parameter. Let's add another 10 on there. Let's save. And let's run again. Right, and now the result is 33. So you can combine a variable argument list with a set of formal arguments, but just keep in mind that the variable argument list always has to be the last parameter. So I could do something like this. I could say arg1, right? But that has to be first, okay? Oh wait, actually, not there. Sorry, let's scroll back up. Here in the definition, I can have an argument that comes before the variable arguments, but all of my named parameters have to come before the variable argument list. This guy always has to be last, so that way the interpreter knows which of the parameters to assign to the variable list. All right, so that's a quick introduction to defining functions in Python. One of the most common operations of almost any program is making decisions. Your program will often need to compare different values and execute code based upon some logical outcome. And that's where conditional logic comes into play. So in the code editor, I'm going to open up conditionals_start. And in Python, conditionals are handled using the if statement. And so you can see here in the main function, I've got 2 variables, x and y, and they are 10 and 100 to start with. So let's go ahead and add our first conditional statement. I'm going to write if x is less than y, and then I'm going to assign the result variable to the string x is less than y. And then I'll just print out the result. All right. So the code compares x to y, and if x is less than y, then you can see we set the value of this result variable, and then we print it. So let's run it. And I'm going to run this in my terminal. And you can see, sure enough, x is less than y. All right, so it seems to work just fine. Now, let's go ahead and close this terminal, and let's see what happens if I change the value of x to be something like 1000. So I'll run this again. Right? And now I'm getting an error. It says local variable result referenced before assignment. And the reason I get that error is because since x is no longer less than y, this code is no longer executed. So my print is trying to print the value of a variable that was never declared. So we have to figure out a way to add in the case where the test condition is false. So let's close the terminal and make that change. So I'll write else result is equal to x is greater than y. All right, so now I've got both conditions handled. So I have the if condition, which will test this condition, and then else. Else will run in all the cases where this evaluates to false. All right, so let's run this one more time. And sure enough, now we're getting x is greater than y. Okay, so now let's try one more thing. Let's make them the same value. So I'll save and I'll run. And, well, I'm getting x is greater than y, but that's not really true, right? They're the same value. And the problem is that this condition here evaluates to false, so we're kind of just assuming that x is greater than y because it's not less than y. So that's not really correct. We have to check to make sure that x actually is greater than y. So we'll make one more change to fix this particular problem. I'm going to write elif x and then 2 equals and then y. Set the string to be x is the same as y. All right, so now we have if, we have elif, and we have else. So this gives us a way of chaining more than one condition together, and you can have as many elif statements as you want, right? So now we're checking for the special case where x and y are the same. So if we run this, and sure enough, we get the right result. X is the same as y. All right, so there's another way of writing conditional statements. Sometimes you'll run into situations where you have just an if and just an else, and so you'll have like 4 or whatever lines of code intended to do just a simple comparison. Python has a construct called a conditional statement, and the conditional statement lets you write a common if-else construct all in one line. It's a more concise way of writing the comparison logic. So let me just write the statement and you'll see what I mean. So right here, I'm going to write result equals